Okay, so let's look at the next step in glycolysis. We've covered GAFA in Gaffa's chef. We are up to step 4. G, add a phosphate, fructose version, add a phosphate, and then we're up to the S in Gaffa's chef. And the S is going to stand for split. We're going to split the fructose 1,6 bisphosphate compound into 2 3-carbon compounds. So let's redraw that compound. I hope you're drawing all of this along with me, and if you need more time to draw, just hit the pause button. So where are we going to cut this? Well, it's an alpha D. Fructose 1,6 bis phosphate. I'm going to abbreviate for now. Where are we going to split this molecule? Well, we're going to split it here between the ring oxygen, NC2, and we're going to split it here. This is 1, 2, 3, 4, between 3 and 4. And this is what's going to give us 2 3-carbon compounds. The 2 compounds this is going to split into are called dihydroxy acetone phosphate and glyceraldehyde 3-phosphate. This is where we have to start to understand what functional groups are, because for the rest of these compounds, if you understand the functional groups in the compound, then you can draw the compound from the name alone. So before we continue with step 5, let's look at dihydroxy acetone phosphate. Let's look at the name and see if we can figure out how to draw that compound. Well, di we know means 2, and hydroxy means OH. Here's the hydrogen part of it, and here's the oxy. It's telling you it has 2 groups in it that have an O and an H. What else can we get from the name? When we look at acetone, we see the O and E. That's telling us we have a ketone. And acetone happens to be the simplest of all ketones. A ketone is just a carbonyl group that lies between other carbons. Now, acetone is the simplest of the ketones, so there are only 3 carbons, and we know this is going to be a 3-carbon compound. So we know when we draw this compound, it has 3 carbons, and in the middle we have a carbonyl carbon, or a carbonyl group. And it tells us one more thing. It tells us I have a phosphate. So let's see if we can figure out how to draw dihydroxy acetone phosphate, which we can call DHAP for short. First of all, we know it's a 3-carbon compound because we're breaking down our 6-carbon compound into 2 3-carbon compounds. Now let's look at the name. It's telling them di. I have 2 hydroxy groups. And I have an acetone. Acetone is where I would start drawing this compound. Then I'm going to put that ketone in here right away. The ONE is telling me I have a ketone. Dihydroxy is telling me I have 2 hydroxy groups. And we know carbon needs 4 bonds. So I'm just going to go ahead and fill the rest in with hydrogens. But now what do we do about this phosphate? We're going to go ahead and eliminate that hydrogen and that's where we're going to add our phosphate on. So here's our compound, dihydroxyacetone phosphate. And our finished product looks like this. Now, if we wanted to, we could make a simpler drawing, and we could say CH2OP on top, ketone, and CH2OH. You might see it drawn either of these two ways. Let's look at our other compound that alpha-D fructose 1,6-bis phosphate breaks up into, and we can analyze that name also. And that other compound is, glyceraldehyde 3-phosphate. What do we know about glyceraldehyde 3-phosphate? Well, anytime you see glycer, you know that it comes from a compound called glycerol. It's a derivative of that. What do we know about glycerol? It has 3 carbons, and glycerol, that OH, is our alcohol ending, and alcohols have our OH group. Well, glycerol happens to have 3 OH groups, so I'm going to go ahead and draw those on. So here's our glycerol. But we're not drawing glycerol here, we're drawing a glyceraldehyde. So how do we turn this into an aldehyde? Well, an aldehyde looks like this. It's got a carbonyl carbon and a hydrogen. So it's always going to be at the end of a molecule. Glyceraldehyde 3-phosphate. 1, 2, 3. Here's our aldehyde. Now, notice it's in the name, so that's our functional group. You always put a functional group in a name on C1, or as close to C1 as you can, because you noticed in acetone, ketones have to be at least 1 carbon in. But the rule with the naming organic compounds is you want that functional group on C1 or as close to C1 as possible. So we're going to go ahead and put that aldehyde on C1. What else do we know? We know glyceraldehyde is derived from glycerol, and there's one other modification we need to make to this compound. If this is C1, the molecule name is telling us to put a phosphate group on C3. And that's the only other modification we need to make. So let's redraw this molecule, remove the H, and put in a phosphate group. So glyceraldehyde 3-phosphate that's abbreviated. Glyceraldehyde 3-phosphate looks like this. And now we can go back and we can pick up where we left off, which is on step number 4 of glycolysis, because now we know how to draw these compounds. Where we left off was fructose 1,6-bis phosphate. We're going to go ahead and redraw that. CH2OP, OH down for alpha, up, down, CH2OP. So when we cut this molecule in step 4, we're going to end up with, they're off. Oh, we just faded off. Okay. So we're back. So now we're going to draw the dihydroxyacetone phosphate, DHAP. Of course, we never abbreviate on the test. And let's see what that looks like. Here's our acetone. Here's our hydroxy. Dihydroxyacetone phosphate, and we know the other compound that fructose 1,6-bisphosphate becomes is glyceraldehyde 3-phosphate, which we know derives from glycerol. Glyceraldehyde 3-phosphate. We know that derives from glycerol, but we know it's an aldehyde, so on C1 we're putting our functional group aldehyde. The rest is like glycerol. We have an OH. And we know that on the third carbon, we have a phosphate. So that's step 4. Now step 5 is very nice, because what we're going to do is, for step 5, is simply convert the DHP that we produced into glyceraldehyde 3-phosphate. So you already know how to draw those two structures for step 5.